Good evening, everybody. Thank you so much for coming here to the Marine Biological Laboratory for our Resilient Woods Hole Symposium. My name is Leslie Ann McGee, and I'm from the Woods Hole Oceanographic Institution, and I am the Initiative Manager for Resilient Woods Hole. And we also want to welcome all of you who are joining us via Zoom tonight. I think we have about 85 of you in person and about 250 of you on Zoom. So we're very excited that this has attracted so many people. It's obviously a piece of work that the three institutions have been working on for the last couple of years. It's been near and dear to our hearts, and we're very excited to bring the community in and expand our initiative beyond the interests of our three institutions. So for our in-person audience, safety is our priority, so just wanted you to take a note of the emergency exits, which are behind you or up here on the front in case of an emergency. Also, masks are required at all times for audience. When you are asked to use the microphone to ask a question, please leave your mask on. It will pick up your question through your mask. Speakers will be able to remove their masks during their speaking and Q&A periods, but we will remain socially distant. And we have allotted time at the end of each panel for questions and answers. We're very excited to gather your questions and answer them, as many of them as possible. In addition, our rapporteur in the back from MBL, Diana Kenny, will be taking the questions from the online Zoom platform and will be sharing them with us as we go as well. So for those of you in the audience, we handed out, or in the back, there's a piece of paper with the agenda and some space for notes at the bottom, as well as pens, so you can jot down your questions or your notes as we go through the panel of speakers. For those of you joining online, please submit your questions during the panel in the Q&A function on Zoom. In-person questions will be asked by roaming microphones, so you raise your hand, we'll bring you a microphone. Again, Diana will be reading some of the questions from the online Q&A. So our goal tonight is to share with you a real breadth of information, really to franchise you into this discussion, engage you in the future planning for the effects of climate change as we're seeing them today and in the future. And we want to ensure the future of Woods Hole in light of these changing climate conditions. We want to start a conversation with you, so we're really excited that you're here tonight. We have some opening remarks from Nipam Patel, who is the Marine Biological Laboratory Director. He is also a professor at the University of Chicago, and he joined MBL in 2018 from Cal Berkeley, where he was a professor and co-chair of the Department of Molecular and Cell Biology and a professor in the Department of Integrative Biology. He is the 20th scientist to serve as the MBL director since its founding in 1888, and we want to welcome Nipam to the stage. Thank you.
Thanks. Well, welcome everyone this evening to the Resilient Woods Hole Symposium. And I want to, welcome all the audience, whether you're here in person or attending virtually. And the MBL is really pleased to host this symposium in our renamed Clapp Auditorium, Cornelia Clapp Auditorium. And Cornelia Clapp was the first person to arrive at the MBL in 1888. And she received the first and second U.S. PhDs for women in the United States. And so and she played an instrumental role in the early history of the MBL, and we're very pleased to honor her here. And if you go out into the lobby, you'll see the display that we've put out there, Leadership Excellence, honoring quite a number of people who have been underappreciated in their role in science. And so we're pleased to do that. Hopefully you get a chance to go out there and see that. So I want to give a special thanks to the leaders and experts working together from the Woods Hole Oceanographic Institution, the NOAA Northeastern Fisheries Science Center, and the Marine Biological Laboratory, who've begun phase 1 and 2 of the project about a year ago. And we have a vested interest in this problem here in our community because the effects of climate change are inevitable. And there were great reasons that our institutions were founded in this location, and it has a lot to do with the environment that we're in, being on the coast. But we have the inevitable situations that we face now as climate changes and storms increase. And so it's very important that we work together, all the institutions and the community here in the Woods Hole area, to understand the best way to move forward with the challenges that we have. So this evening's symposium is an opportunity for you to hear an update on the phase 3 planning for a Resilient Woods Hole initiative. And with that, I welcome Leslie Ann McGee, the manager of the Resilient Woods Hole initiative, to begin the program. Thank you.
Okay, we are going to welcome our first panel up to the illustrious stage here. So if I can have our 3 scientists come join us. And then just a reminder to advance the deck, I think, wherever Carrie is. Great. So we thought in our first panel we might want to take the opportunity to share with you all some of the science that's going on at the 3 institutions relative to climate change. And these are going to be really quick flash talks on really complicated long-term studies that our scientists at WHOI and NOAA and MBL are doing. And to give you sort of a frame of reference for the work that is going on in this lovely village that we all love and care for. And so my first speaker on our our science contributions is Carol Ann Clayson from Woods Hole Oceanographic Institution. Carol Ann is a senior scientist at WHOI. She's also the director of the Oceans and Climate Change Institute at WHOI and the institution's associate director for research strategies. So she wears a few hats at the institution. Her research covers the areas of high-resolution air-sea interactions, satellite remote sensing, and ocean modeling. So I will turn it over to Carol Ann. And if you all could advance the slides. Oh, sorry, that's my fault. My fault. I'm supposed to be advancing the slides. You have it? Keep going. Perfect. There we go. You're good at this.
Thank you very much. It's a pleasure to be here tonight. I'm going to start my stopwatch just to make sure that I stick within 6 minutes. I'm just going to give you the briefest possible high-level overview of a little bit of the climate science that we do at Woods Hole Oceanographic. As we know, the ocean really defines our blue planet, provides half of our oxygen, most of our water, our food, transportation. The ocean takes up, and I'm going to refer again to this in just a moment, but the ocean takes up the vast majority of our excess human-induced heat, like about 93% of that, and more than a third of the excess atmospheric carbon. And the ocean we know as changing in ways that will impact our economy, national security, and health. And it touches on so much of climate is within the ocean. So I'll just point out at this moment that we have over 800 projects ongoing at Woods Hole, and well over half of those are related to aspects of our climate system. So I obviously can't give you a synopsis of 400 different projects at this particular moment. So I'm just going to, we've lost the title of all of these. So this is a figure of Argo, which is a global ocean network. You can see it's a global array. Those dots are where there are currently Argo floats. And if you look at the floats themselves, I'll get this. So the floats come up to the top, then they sink down, go back down 10 days later, come back up, and relay information about temperature and salinity to a satellite. And that information then gets relayed immediately to scientists and the public at large. And one of the important things about this is that when we try to talk about how much heat is going into the ocean, the Argo system is the premier way of understanding this. So it is an international collaboration. You can see the number of contributors across the bottom. Woods Hole Oceanographic contributes more than 10% of the entire global network of Argo floats. That is one of our major climate things. When you look up scientific papers, and if you see all the time things in the Washington Post or the New York Times, and they're talking about changes in temperature and where the heat is going, where the salt is going, so often there's a reference to Argo. That's a really key part of our climate database that we produce. Another major project that we have that Woods Hole is in charge of is actually a National Science Foundation project on the Ocean Observatory's initiative. We call it OOI. And this was actually the largest grant that has been done from NSF towards a project of this kind. And who he is in charge, runs the organization. Other universities do different components of it. We look at and service several of the different buoy moorings that are sitting out there. So they're sitting in different places in the global ocean. And it's not just a buoy, it's an entire system with multiple buoys, multiple underwater profilers and gliders, and instruments of all kinds. And again, this is a major platform from which we can observe changes in the ocean and relate those to things happening in the atmosphere, because we're making some meteorological variables as well. So you can see physical, chemical, geological, biological properties all the way from the near surface or the near atmosphere all the way to the seafloor. And this encompasses about 500 autonomous instruments that we're keeping track of and getting the data back from. And the data is freely available to users worldwide, including anyone in the scientific community, policy experts, decision makers, educators, and the general public. So this is just another one of the many large projects that we have at Woods Hole, really trying to understand different pieces and components of our climate system. And this one has animation. So this project is a new project that is just now getting underway. And if you can see the map here, you can see that what we're talking about now is Woods Hole, Martha's Vineyard, and Nantucket. These colors down here are the wind farm lease areas, and the different colors indicate the different companies. So as part of a new Department of Energy large project that Woods Hole is leading, we are going to put a lot of assets into the water, and I just want to highlight a few of those here. This first one is something that you might have seen if you've been on Martha's Vineyard and you look down to the south. First of all, there's the onshore Martha's Vineyard Coastal Observatory, and offshore, there'll be a better picture in a moment, of the Air-Sea Interaction Tower, which was built specifically to understand the science of what's happening between the ocean and the atmosphere and waves, and see how that is going. That has now been out there for 20 years. So we're starting to get a climate data record from that as well. That is a real local treasure. There is no other tower that has been built for that purpose. People have repurposed different types of platforms to get measurements. This was designed specifically to get the right type of what we think of as turbulence measurements, that chaotic motion in the ocean and the atmosphere. It's because it has low flow distortion. So that's a significant thing that we do. And there's a picture there of ACIT. And since my husband's here in the audience, he was instrumental was a co-builder of ACIT 20 years ago. So usually I have a picture here where he's sort of hanging off of ACIT back in the day when we didn't worry about buckling up and hat and helmets and all kinds of things. But I point out we are much more careful now in terms of what we do. This project will have this is a LiDAR buoy, so it uses remote sensing, so it's not actually putting an instrument into the atmosphere, but measures things. You can see aerosols and dust and critters in the atmosphere, and so it gives you information about winds up through from the surface to about 200 meters. There's what we have as well, the long-term ecological research, which is a big program running also out of Woods Hole. They have it's again on ecology and worrying about biology in the area. They have assets at the Air-Sea Interaction Tower, and they also run this line multiple times a year as they come down and they make measurements down to these 3 dots down here, which are part of the OOI, the Pioneer Array. So you can see as we start to build this out, we are also going to be adding different types of buoys sitting out in the water. Many of those, the ship will be taking balloon measurements, and there will be more things in the water, more gliders moving around, getting more oceanographic instruments. There will be, you notice on land, there'll be radars getting, again, really characterizing the ocean and the atmosphere. And kind of a key piece is what we call the large barge, which will be a barge that will be anchored down within the lease areas themselves with a tower on it that has a lot of instruments and is going to be like a key feature of getting these wind and temperature and humidity measurements like up through the atmosphere. Key. All right. So my last slide here, some new institutional initiatives that I'll spend a minute on. We have the Francis E. Fowler, the 4th Center for Ocean and Climate. So this was a new bequest that came to us that we are using to allow WHOI scientists and engineers looking at spending time thinking about climate issues and also communicating results. We have the new Ocean and Climate Innovation Accelerator, which is now a partnership with ADI, a company, somewhat local company. We have others that are looking to join that, and that's, again, an attempt to bring together industry, academia, and philanthropy to accelerate, to develop and accelerate new climate change solutions. And lastly, of course, we have our sustainability goals and climate resiliency commitment, including commitments to how we're building, commitments about what we're going to do with our dock system in terms of what's happening with sea level rise, and lastly, of course, ResilientWoodsHole, which we'll hear again more about tonight. Thank you very much.
Thank you. Thank you so much. Now that I realize this is my responsibility, I'll take the baton. Next up is Jerry Malillo from the Marine Biological Laboratory. Jerry is a distinguished scientist at MBL and the professor of biology at Brown University. In 2014, he was elected a member of the National Academy of Sciences. His research team focuses on understanding the impacts of human activities on the biogeochemistry of ecological systems using a combination of field studies and simulation modeling. Welcome, Jerry.
Thank you very much. Does this just work like normal?
Yep.
Okay.
That's the
Got it.
forward, that's the back.
Okay. Well, pleasure to be here and to represent an amazing place, the Marine Biological Laboratory. Oh, I can take my mask off, I forget. At MBL, you don't take your mask off from anything, so I just want you to know. So with the founding of the Ecosystem Center in 1975, a climate change research program was established at the MBL. Over the next few minutes, I'm going to talk about 3 projects at the Ecosystem Center that focus on climate change issues. And I'll begin with climate-related studies at the Plum Island LTER Long-Term Ecological Research Site north of Boston. This slide is courtesy of Ann Giblin, by the way, who directs that program. The uplands, marshes, and saline estuary of Plum Island are experiencing various aspects of climate change, including increased heavy precipitation events up in the upper left there, warming ocean waters, and sea level rise. Since it was established in 1998, the LTER, led by Ann, as I said, has been studying the consequences of climate changes for the biology, chemistry, and physics of the ecosystems in this area. A core research effort at PI, the Plum Island Ecosystem LTER, focuses on sea level rise and the fate of the area's magnificent marshes. If you've ever been there, it is just a spectacular place with marshes as far as the eye can see. Measurements of key indicators, such as net carbon storage in the marshes at Plum Island, indicate that they are currently keeping up with sea level rise, which is good news. However, to quote Ann, we don't know what's going to happen in the future, and part of it depends, of course, on the rate at which sea level will rise, and our friends at the Oceanographic are going to take care of that part of the problem for us. Okay, moving on, since time is short, I want to talk about the global carbon cycle. Emissions of CO2 to the atmosphere from human activities is driving climate change. We all know that. The graph on the left there indicates a relationship between CO2 and global surface temperature. And you can look at the global carbon cycle as having two major components, the sources and the sinks. And here is a quick accounting of a recent decade of the global carbon cycle, and these are annual numbers. Emissions account for 90% of the sources, and these, emissions from fossil fuels account for 90% of the sources, and emissions from deforestation in the tropics currently accounts for the remaining 10%. Where does this carbon go? It goes into the atmosphere, and it has three primary fates. The first fate is the amount of carbon remaining in the atmosphere, and that's about 45% of the total emissions. The second fate is uptake by the oceans, currently in the range of about 25%. And the third is uptake and storage in land ecosystems, and that's about 30%. And so that is why I have been particularly interested in the global carbon cycle in terrestrial ecosystems, because the land sink is absolutely critical to maintaining climate on the planet. And protecting those systems is absolutely critical. To study the global carbon cycle at the global level, my research team and I have built a simulation model that basically tracks the movement of carbon, nitrogen, and water in land ecosystems through time. And we do this with a relatively reduced form model, the structure of which is shown on the left, and the boxes represent stocks of carbon, and the arrows represent exchanges of carbon between those stocks. So there are plants and soils and so on. I can't go into the detail right now. And basically, we have parameterized that model for 24 to 30 different types of land ecosystems globally, using all of the data that we can get our hands on out there to parameterize those models. And then we put a model of this type down in each of 60,000 grid cells across the terrestrial landscape. And we then run that model driven by a whole series of parameters like precipitation, temperature, CO2 concentration, and so on. We run those models at a monthly time step, and we predict basically the cycling of carbon, nitrogen, and water in land ecosystems for the surface of the globe. And then we check it against field measurements that are made in various places at specific times. So this modeling effort has been an interesting one, and we have used it to inform policy. I'm going to give two very quick examples. The first has to do with a collaboration that my research team and I had with Chinese scientists at the Chinese National Academy of Sciences. And they were interested in how they were going to manage their landscape in order to store additional carbon, because China is the biggest CO2 emitter currently through fossil fuel burning. But they have a history of emitting carbon in other ways. And so we used our model with environmental historians, geographers, and remote sensors to build a history of land use in China, and then look at what the sources of carbon were to the atmosphere and what the sinks were. And the take-home message from this story is that over the 20th century, changes in land use were the major drivers of loss of carbon from land ecosystems in China. And this was a period of time when China added 800 million people to their population. It was also the time during which there was the Great Leap Forward and the cutting of a lot of forests and so on. I mean, it was a very dynamic time, but that purple area represents that loss. The second example I want to give is one that we did with a group at MIT. And here we looked at how you could use land to reach the then 2-degree climate target that was in the Paris Accord. Take-home message from that is we think that land can be used to actually get very close to a 2-degree target for global temperature increases relative to pre-industrial times, but it requires a pricing of carbon on land. And if you lose carbon from your land, you pay for that carbon. And so a really interesting set of results there. And then finally, I just want to talk about a long-term experiment that I've been running for 30 years at the Harvard Forest in Petersham, Massachusetts. And here we're asking the question, articulated up there in the upper left-hand corner, will global warming trigger biologically mediated feedbacks to the climate system with basically warming begetting more warming? And to cut to the chase, the answer is after 30 years, we've lost about 20% of the soil carbon when the soil is heated 5 degrees above ambient. And our experiment, which was the first of its kind anywhere in the world, has now been replicated in a number of places. And the results in these places, the tropics, the boreal forest, and so on, show similar results. So this is not the bright side of the news, but these feedbacks in the climate system are absolutely critical to understand. Thank you.
Thank you very much.
Thank you.
Take your mask, Jerry.
Oops. Don't ever go anywhere without it.
Okay. Up next, Paula Frat. I asked her how to pronounce her name. I think I got it right, very phonetically. Paula is the chief of Oceans and Climate Branch at NOAA's Northeast Fisheries Science Center right down the street. Paula provides scientific leadership to multidisciplinary staff responsible for collecting and analyzing physical, chemical, and biological observations in support of ecosystem research and the management of living marine resources on the Northeast U.S. shelf. So, welcome.
Thank you.
To you. Welcome.
All right, good evening. So the various branches of NOAA, the National Oceanic and Atmospheric Administration, all are guided by one central mission that's here: to understand and predict changes in climate, weather, oceans, and coasts, to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystems and resources. Now, the Northeast Fisheries Science Center, with offices right across the street from where we're sitting, is under NOAA Fisheries, one branch of NOAA. And the mission of NOAA Fisheries is a bit narrower than that and focuses on the stewardship of ocean resources in particular, and activities that will provide for sustainable and productive fisheries, safe seafood, recovery and conservation of protected resources, and healthy ecosystems. So I know we're talking about Woods Hole here and Woods Hole institutions, but I do want to take a moment and point out to you that the Northeast Fisheries Science Center does have facilities in ranging from 5 different states, from Maine to New Jersey. So the work that I'm going to briefly outline here is done at all those locations, not just in Woods Hole. The climate research that we do at the center can be broadly binned into 3 different categories, 3 different themes. One is tracking climate-related change. 2 is understanding the mechanisms that lead to change and the impacts on the ecosystem. And the 3rd is forecasting and projecting changes into the future and being able to respond to those changes, so through management. So we'll go through each one of these quickly, one by one. You can't do climate change research without having observations of what current conditions look like and how that compares to what they looked like in the past. So that involves monitoring, and that's something that the Northeast Fisheries Science Center does very well. We have a long history of monitoring that dates back 50 years in this region. What I'm showing you on the left there is a map that is representative of 1 year's worth of effort of observing by the Northeast Fisheries Science Center, by actually my group, the Oceans and Climate Branch. Each dot on that map represents a location in the ocean where we took a ship and we put some instruments in the water and we measured something about the ecosystem. So we measure across all our surveys, not just in my group, we measure pretty much everything about the ecosystem, from physics to fish to marine mammals to birds, all the way to human systems. So we cover everything. We put instruments in the water to measure physical properties like temperature and salinity, that was already discussed. We tow nets that will collect plankton, will collect fish eggs, will collect fish larvae. We collect water samples at various depths in the water column to learn about the biogeochemistry and how that's changing. And we have resource surveys that target specific parts of the ecosystem, like finfish and invertebrates, marine mammals and birds, and so forth. So with that, we paint a complete picture of what the ecosystem looks like right now and what it looked like in the past. So the second theme that our ecosystem or our climate change research falls into is understanding the mechanisms that are driving change and how that change sort of ripples through the ecosystem. So the Northeast shelf, U.S. shelf, is influenced by several drivers that can lead to change, right? And when we talk about climate change, we're mostly focused on the physical drivers, so how the physical environment's changing and then how that ripples through the creatures that live in this environment, right? So our researchers are looking at various ways that the physical system can influence things like habitat. So we know that if you have a physical change like warming, that changes the habitat that might be favorable for certain species of fish to live in, right? And as that habitat changes, sometimes the fish have to move. So species distribution might change. It might change how well they reproduce and how well they recruit back into that fishery again. So their abundance might change. We also look at what are the physical effects, the biophysical effects on an organism when the temperature changes or when the ocean acidification gets higher. Does it grow slower? Does it eat differently? What's its metabolism like? Those sorts of things. We also look at, as habitats change and species move, you can get different overlaps in habitats, right? So species are going to interact. They're going to be put together, and then the predator-prey relationships are going to change in that ecosystem. So you can see how physical changes can directly and indirectly lead to changes in the ecosystem. So that's something our researchers use the observations we collect directly from the ships, satellite observations. Sometimes they're doing controlled laboratory studies to look at biophysical response in an organism. And sometimes they're using all of that information with fancy numerical models to understand the ecosystem as a whole. So the third area is you can't just look at the past, right? If you want to understand the change and then do something about it, meaning manage your living marine resources better, then you need to be able to say something about what you think is going to happen in the future, right? So the third area of research is forecasting and projecting conditions into the future, and then what do you do about it? How do you respond, right? So in order to forecast change, we have to use models as sort of a crystal ball to look into the future. You've probably heard of global climate models that they use in, for instance, the big IPCC reports that tell you, 50, 100 years from now, what the ocean temperature is going to be, what the response is going to be. So that is represented there on the very left. There's all kinds of models we use to try to predict physical changes in the ocean into the future. So the global climate models are sort of like a weather model, right? You know the physics that control how the land and the atmosphere and the ocean interact, and you predict across the globe what the physical conditions look like. So then that does a pretty good job, but that is pretty coarse resolution. So sometimes we need to think about going to regional climate models, which is something we're working on now, to get better resolved processes in places that are complex, like the Northeast U.S. shelf. Once you have those skillful predictions, you can then use those to predict things like species distribution and abundance, like we talked about in the science on the previous slide. You can use those to construct new habitat projections. If I know in the future what the temperature is going to be across my area, I can tell you what species are going to want to live there, right? You can use those to assess the vulnerability of certain species if you know something about what they're sensitive to. And then you can take all of that together. You can do scenario planning and all kinds of other things to help your fisheries managers make decisions in an agile climate ready way. So I don't have time to go into this slide. I'm going to stop here. I will leave this up here. But I wanted to put up a little bit, like a teaser of some of the things we're seeing in our ecosystem here on the Northeast U.S. shelf. And you can read through them, but some of the highlights are, warming is happening, and it's happening really fast in our ecosystem, faster than most of the world's oceans. We're getting more frequent interaction with the Gulf Stream. We're getting longer and more intense marine heat waves. We're seeing shifts in water properties, more acidification. And then there are some of the ecosystem responses down below. I'm going to stop here because I don't want to cut into our question time, but thank you.
Thank you very much. Okay. So you have the opportunity tonight to ask questions. We have 3 eminent scientists in different areas of studies at our 3 institutions. We also have 3 other institutions in Woods Hole that we'll be highlighting at our follow-up symposium, which will come at the end of phase 3. But we wanted to take your questions from the audience. And I wanted to just tell you, Jerry, that did you know that Paula is your neighbor? Oh, right. And then, Caroline, did you know that we're Buffaloes?
Yes, I did know.
Caroline did her graduate work at the University of Colorado. Go Buffs. So we all have something in common here. So I just wanted to lighten the mood tonight a little bit. So we're going to take some questions and answers from the audience first. So if you have a question for any of our scientists on any of the things they presented, or if you have any questions you've always wanted to have answered about climate science and some of the work that's going on at the institutions, we'd love for you to ask them now. And you can just raise your hand, and Carrie and I will come by and give you a microphone. So who would like to ask a question first? I know, who's going to be the first guinea pig? Oh, I'm in the corner.
In the second presentation, you talked a little bit about managing ecosystems for carbon sequestration. I was wondering if you could talk about that a little bit more and kind of what you see the future of like changing land management for that specific ecological function.
So Jerry, her question is about managing carbon using terrestrial land use principles. Is that correct? And what you see the future of that is, or what would need to change?
Question, and something that's on the minds of a lot of people, especially coming out of the recent COP experience in Glasgow. The management of land carbon is quite tricky because it depends on nation states and what their situation is and what they're willing to do and what resources they have to do what they'd like to do. In the modeling that I was talking about, we did a lot of consulting in developing different scenarios to explore. We consulted with NGOs and governments around the world, actually, talking about their different visions. And there are a couple of things that people agreed must be done. The first is to, at all costs, maintain forest carbon stocks now, because they're a big reservoir of carbon, probably a century worth of emissions or more of carbon at projected rates. And secondly, they're actively continuing to accumulate carbon. So you want to save forested ecosystems in particular, because wood is a great carbon storehouse. The second thing is you can use some non-forested lands to begin to swap out biofuels for fossil fuels. And this becomes a tricky business, because if you're going to grow biofuels for production of energy, you're going to need a lot of land. And there is some land that is suitable. It is not highly valued now and used for other things, although it does have cultural value to many people. But adding a biofuel mix to the energy system is thought to be a productive way to go forward, but it does come with some costs. And one of the costs is the possibility of displacing current croplands with biofuels. And that affects food prices, and it particularly affects, in a significant way, food prices in the global south. And so there are unintended consequences that you have to watch out for. And then finally, which I mentioned before, one of the ways to preserve forests is carbon pricing. It's a nice way of saying carbon tax. But a signal must be sent to people not to touch the carbon in those systems. And if you do, you have to pay for that emission. And that turned out to be, in a number of the scenarios that we ran, the most critical thing that had to be implemented. I don't know whether this helps. I cited a paper in there, and if you email me, I can send you a PDF of it. It's jmalillo@mbl.edu. But it was a widely distributed and much talked about paper in about 2014, and we followed up with several others since then.
Thank you, Jerry. And that's a good reminder that if you have any questions that you think of after you go home or after you sign off, you can always email them to our initiative at info@ResilientWoodsHole.org, and we will make sure to sort it and get it to the right person who can help you answer that question. Diana, do you have a question from our online audience?
Yes, we do. How do you test your models against actual measurements and data?
Okay, so I'm going to ask Paula. Okay. or I'm coming back for you, Caroline. Don't worry.
Oh boy. Yeah, there's a lot of things you can do. Some models will pull data in and essentially what we call assimilate the data to push the model towards more realism. But most of the models what I was talking about up on my talk was mostly it's about, comparing in the region that you're looking at and doing statistical tests to see how close the model is getting to reality. You can do things for projections. You can do things like testing the model during an era where you do have observations. You can essentially remove data from your model, remove data points and predict in those points and then compare that to actual observations and say, how well is this model predicting what it thinks is predicting in that location at that time? So those sorts of games can be played. I don't know, you want to add?
No, that's good. I'm still coming back for you, I promise. Okay, another question from the audience. Do you want to take it, Carrie? Or? Okay, great.
Thank you all. My question's for all of you, I guess.
It's going to Carol Ann. I'm just going to tell you that right now.
Oh, okay.
But please go right ahead.
So it's pretty evident that a lot of data streams are available and being gathered by different institutions, yours and lots of others. And I'm wondering what kind of efforts that you might know of are to federate those data in a way that can increase the granularity, that can be used to be more predictive, and maybe come up with ideas that you might not otherwise have from your theory. In other words, data-driven ideas patterns you might look for that you wouldn't see in individual groups of data sets.
Thank you.
That's a very good question. And that is certainly one of the things that oceanography and climate science in general has really been working towards, is to make sure that our data is open and widely accessible, and that we have a really good reference information in it. How was that data taken? What are the errors associated with that data? So that people can start to do aggregations of these data sets and put them together for various purposes. And one thing just to follow on, the questions about the modeling. A computer model is just the representation of our mathematics. And we don't have mathematics necessarily in the model if we haven't seen that phenomenon in our data. Okay, so the climate models themselves, they don't come up with their own new physics, right? We have to put that in. And where do we get that from? It's from looking at the data, right? So there's a really important component that data plays in the creation of models, in the driving of models, and in the validation of models as well. And that is certainly, as time has gone on, we have really worked much harder to make sure that all of these data sets get curated and made available to the public as rapidly as possible. One of your points, though, was about sort of in some ways, the spatial resolution or how much data is available in any given area. And I'll just give an example of the Argo data set that I showed you. It looks really impressive, right? It's like more than 3,000 of these in the global ocean. What we've done on that map is to make the dots very, very, very large compared to the space. So you look at that and you're like, oh. In fact, The Hunt for October on TV as I was cooking the other day, and they're talking about they've dropped so many things that one could walk from Iceland to Greenland to the U.S., on the number of things that have been dropped in the ocean. It kind of looks like that from that picture. But 3,000 over the entire global ocean is still much more than we've had in the past, but it doesn't give us, a very high resolution picture. And for that, then we tend to have to put a lot more instruments in the water and do things on the surface with satellites and other things to try to get that resolution better.
Thank you very much. I think we have another question up here, Carrie, in the middle. That's okay, and then we'll go to a question online.
Thank you. Back when we didn't know that hurricanes were coming, will we know when the Gulf Stream is going to stop?
Okay, that's up for grabs. Will the Gulf Stream stop, and do we know if it's going to stop?
I'm not going to say it's stopping, but there has been a lot of discussion about, is the Gulf Stream slowing down, right? Because obviously that has significant implications on our global climate, European weather, our weather here, fisheries, how the Gulf Stream is changing. And it is interesting because that example of, what the Gulf Stream is doing, there was a while where we had a little bit more concern about the slowdown of the Gulf Stream. And some of that was caused by the fact that we had very, very few measurements. And so what happens is when you take measurements pretty infrequently, it's hard to remove. Sometimes you get a seasonal signal, right? If you take something at one time of the season versus another, that can cause what we call a bias in what we're looking at in terms of a long-term trend. Interannual variability, year to year, decade to decade. And so, that has been one of the real troubles, or not troubles, but difficulties with doing a lot of our climate analysis is that, even when we have data, sometimes it's taken very infrequently and you're trying to recover a climate signal from that one. But that is still a question that we have been working on, and I'm not sure stopping of the Gulf Stream is ever something that's going to happen, but, the question of if it's slowing down, and if so, kind of at what rate, and what does that mean in terms of heat moving through the whole global ocean system is a real open science question.
Great, thank you. We'll take one more question from the online contributors. Do you have one, Diana?
Yeah, we have several, and I'll have to say in advance, I'm sorry we can't answer them all tonight, but we will try to address them after the symposium. There's a couple of related questions just about on the personal level. What role does citizen science have in the study of climate change, and what can individuals do at home to reduce climate change?
Okay, I'll give the citizen science question to Jerry.
I was thinking about the earlier question.
You just need to talk into your microphone.
I was thinking about a couple of the earlier questions, and citizen science came to mind right away. And one of the ways that citizen science is very valuable is for model checking. And they can be a source of data, especially in the terrestrial landscape, to check one's models. For example, if you're building a model that projects land use change, there are people on the ground who are observing exactly what is going on. And there are groups around the world who are now beginning to marshal that information and use it as a validation data set for some of their modeling activities. And I must say that I've really appreciated the National Science Foundation and some of their programs supporting the citizen science programs around the country on various topics. And I think it's a critically important and currently underutilized resource.
Paula.
So I just wanted to quickly highlight that we do some form of citizen science in NOAA at the Northeast Fisheries Science Center in working with industry and fishermen to help. They're out there fishing, and we put instruments on their boats and have them collect measurements for us as well. And that adds to our database of observations in a really fundamental way. So in a sense, that is a citizen science service that we use. We also have a very strong program called eMolt, where we put instruments on lobster. We have lots of lobstermen that have been cooperating with us. We're putting instruments on their lobster traps that stay down when the lobster traps are deployed and collect a history of, tens of years of observations of temperature in particular. So we are engaging with the folks that are out on the water, and both for their intellectual information as well as to help us deploy sensors that can add to our database. So.
Great. Thank you very much. We are going to end this panel. I know there's lots and lots of questions, but as we transition to the next panel at 7:30, I just wanted to say any questions that you asked in the Q&A online, we all have documented. And sir, I know we didn't get to your question during this section. If you'd like to come down during the break, you're welcome to ask it of any of the scientists. And it does lead me to think that probably on our website, which will be launching soon, that we'll start to take some of these questions and create blogs out of them and see if we can't get more of them answered as we go through time. So with that, I want to have you all thank our science panel tonight. So now that we know a little bit about what's going on in the institutions from a science perspective on climate change, we are going to shift into, so what are we doing about it? What are we doing for planning at our local level, our regional level, and our state level? And so we're going to have a 5-minute break, and we'll come back at 7:30 with that panel and get started again. So thank you very much. All right, welcome back, everyone. Thank you for continuing along this journey tonight. We thought we would spend some time giving you some information at the different levels of government about the activities that are going on to address some of the climate resiliency and planning needs that we have. So what we did is we put together a panel for you that looks at local issues with both the town of Falmouth, the regional issues with the Cape Cod Commission, and then also the state issues coming through Massachusetts Coastal Zone Management. You will notice there are 3 people up on our panel. There is a 4th on this panel, and she is joining us live, not from the International Space Station, but from her house. Our original speaker, Steve McKenna, came down with an illness, so Patricia Bowie has replaced him, and she is also a funder of our climate resiliency project called ResilientWoodsHole. We are going to start with Charlie McCaffrey. Charlie is the former chair of the Falmouth Coastal Resiliency Action Committee, so he might look familiar to some of you. He worked for 26 years as the bureau chief of the New York State Coastal Management Program, where he oversaw coastal management plans for local communities. New York's loss is our gain. He also served as Falmouth's representative to the Cape Cod Commission. So I want to welcome Charlie to talk about some of the local planning and resiliency issues. Thank you.
let's see. Where do I okay. What Falmouth faces now and in the future. These are obvious. These are the issues, but the point I want to make is that we realize in town that these forces are for good and for ill. We know that these forces, natural forces, is what created the character of our shoreline, the beaches, the dunes, the wetlands, which we wouldn't have but for these natural forces. And we have to see them, at least in part, as positive and not inherently as threats or hazards. I think this is particularly true of erosion. Erosion is not going to be part of the solution to resiliency because of the movement of sediment through natural coastal processes, building up beaches. So 4 years ago, the Board of Selectmen appointed a committee to look at the issues and to advise the selectmen. That committee finished its work in June of this year and submitted a report to the Select Board. You'll recognize the picture. And I have a few copies if anyone would like one at the end of the meeting. Some of the things that we did during that period, we had an initial workshop to get public involvement and agency involvement as to what are the issues, what are the priorities, what does Falmouth value that may be affected by the increase in these forces. So the first thing we did with money that town meeting appropriated, but since the state is paying for in many communities, we did a vulnerability assessment of town assets, working with the Woods Hole group, who you're also working with. That gave us significant data on all of the town assets that are vulnerable to sea level rise, to storms, to flooding, whether it's a tool shed or a major stretch of road. And it was every segment of road that's affected that was identified. This will be very important as we try to adapt going forward, and particularly it puts us in good stead, I think, for money that might now be available under the $47 billion that's in the infrastructure bill. The town meeting has been very good. They have appropriated, and they are planning to appropriate $100,000 a year to the town. That doesn't sound like much, but it's significant for local government to have that type of money, which the intent is to use for match. So when we apply for state money or federal money, particularly in the planning and design and feasibility types of projects, we can say we've got cash match. So we analyzed the neighborhoods and the private development that's at risk, as well as the town assets. With the Woods Hole group, we developed an approach to do a more detailed plan for one segment of the town's coastline, and that was the Surf Drive area, which I think everyone here would recognize is among our most vulnerable areas, both for the effects on the natural resources of that area, as well as transportation connections. We divided the town into 13 geographic areas that reflect both cohesive communities as well as logical natural areas in terms of coastal processes, and identified that we need to do that type of plan and even more for each of those, just as you're doing for Woods Hole. So there will be that, there's the Surf Drive, Woods Hole, there'll be at least 11 other focused efforts on different parts of the community. We did have several public meetings, and I think we were able to educate the public during those 4 years. what are the resources and uses at risk? Obviously, why we did the vulnerability assessment of town assets, the public infrastructure, particularly our roads, are at risk. Private development, the thousands of homes within Falmouth that lie within the floodplain and will be affected by all of those natural forces. But equally of concern are the natural resources that are at risk. The beaches, the barrier beaches, the dunes, the bluffs, the wetlands, and groundwater as well, because that will be affected. It's the beaches and dunes and wetlands that are at the core of our economic health and the character of the community. So we are equally concerned with how these resources will be affected as to how our built infrastructure and development will be affected. Oh, let me go back. How do I go back? Bottom one. There's a chart here which has forward again. Oh, where's the red dot? No, I'm going, all right. I'm on this, I didn't use the red button. These are the private development that's at risk in each of the neighborhoods that we will be doing plans for. This is sea level rise, so permanent inundation of development. And by 27, the total, that figure down there, 849. That's the current estimate, based on work done by the WoodsHole group, of the number of structures that will be seaward of the high tide line. Some of them can be protected, many cannot. This is important. We provided in our report numerous recommendations to the Select Board of actions to be taken. We broke them up into several categories: the administrative action, actual projects, regulations, education, policy, land redevelopment, future research, etc. The important point about this categorization is that each one of these has to be fully attended to if we're going to be resilient. We have to approach resiliency from all of these perspectives. For example, a key recommendation is we need more staff that are familiar with this issue in the town. So that's a key administrative act, to have the professional capability on town staff to know what the issue is, to be able to address it, to lead on some of these recommendations, and to work to get the money. There is a lot of money from the state and now from the federal government. So we've got to be prepared to get that money. And the purpose of the work that we've done is to make us competitive. Physical projects. You'll hear from Amy in a minute about our moving of the sewer from a hazardous area. So, finally, this is Falmouth Heights Beach. This was how Falmouth became the resort community that it is, beginning in the 1870s. They were drawn by this beach. It's a major beach today. Beaches are an important part. We want beaches to be an important part of the future. But we need to know how to adapt to the changes that will occur, that will drown our beaches and wetlands. How can we adapt so that they are preserved, if not where they are, then just inland? And how can we replace, I hate to say this, but some development that was built inappropriately in former wetlands and on barrier beaches so that we have the protection that makes more development inland safe because it's fronted by a wide beach, dunes, and wetland. Thank you.
Thank you very much, Charlie. Okay. Next up, we have Amy Lowell. Here. Okay, Amy is the wastewater superintendent for the town of Falmouth. She is leading a key MVP program project that will be instrumental in the wastewater climate resiliency efforts in the Woods Hole area. So we wanted to give you an example of a project that's going on right now in this place. So, Amy, welcome.
Thank you.
Go.
Hello. In the evaluation that Mr. McCafferty was just telling you about, that was performed by the committee in consultation with Woods Hole Group and a number of other town entities, they found that some of the most vulnerable municipal assets in town were sewer infrastructure. A lot of the town is actually not connected to the wastewater system. The wastewater division serves everyone in town by being the place where the septage that's pumped from people's houses is discharged. But we do, about 11% of the developed properties in town are sewered, and those properties, many of them that are sewered, are in the coastal areas of Falmouth. Woods Hole, the whole central and low area of Woods Hole is connected to the sewer system. All the institutions, the Coast Guard, NOAA, WHOI, MBL, they're all connected to the sewer system. The Steamship Authority, both their ferry pump out and their buildings, and then the residential area around Eel Pond and Woods Hole are all connected to the sewer system. And then the Surf Drive Beach area is one of the other sewer areas in town that is a very vulnerable part of town very vulnerable to climate change. This photograph here is of our Park Road lift station in March of 2018. That was not a hurricane. That was not a notable storm in particular. I mean, it was larger than many, but certainly not a named storm. And this area, this lift station is at the bottom of Park Road in Woods Hole, and it serves residential properties only. It was built in the 1980s, and the area around that sewer lift station was flooded for a week, because what happens in that area of Woods Hole, as you know if you live or work around here, is that once water comes in to that low area, it takes a very long time for it to drain out. So we, in this particular area, have a problem not just with the day of the flooding, but for quite a bit of time afterwards. That was a very expensive issue, and that is a very vulnerable location. The other figure I have here is on the right is the bike path, obviously, along right adjacent to Surf Dive Beach. But underneath that bike path is the force main, which is a pressure pipe that conveys wastewater from the sewer lift station on Water Street in Woods Hole up to another lift station, and where it ultimately is pumped to the town's municipal treatment facility. The force main is below that bike path, and every year, and often multiple times a year, the highway division comes and pushes stone back up against the bike path and does some backfilling and repaves it. But obviously that is a vulnerable location for the primary sewer force main for Woods Hole, or the only sewer force main for Woods Hole. The town received a grant for $104,000. It's a municipal vulnerability action grant from the EOEA, the Executive Office of Environmental Affairs. And I should mention also that we got a match to that grant. Charlie was talking about the town appropriated funding for matches to do a couple of things. evaluate alternatives to increase the resilience of that Woods Hole sewer force main that I showed you a picture of, focusing on the Trunk River area, which is the most vulnerable area. So we'll be doing an evaluation of options ranging from reinforcement of the area to relocation, and which means literally putting another force main higher up in either Oyster Pond Road or even up to Woods Hole Road. The second thing we'll be looking at is options for modifying the collection system and the collection and transmission system in that most vulnerable area that I showed you in the first picture, which is our Park Road lift station area. And that will include anything from raising that lift station up above floodplain to converting that sewer area to a pressure system, which means each property would have a grinder pump. So we'll be looking at those options over the next number of months. The last thing is preparing a conceptual design of flood-proofing measures for 3 of our coastal sewer lift stations. The Water Street lift station that you may or may not know is there. It's near the MBL saltwater pump station. And Surf Drive lift station, and another one we have that's at the head of Inner Harbor. In addition to those evaluations, we'll be coming up with conceptual cost estimates for our options. We'll be doing some public outreach. We'll have meetings in Woods Hole about these evaluations, and it's actually a short time frame. We will be finishing with this conceptual design and preliminary evaluations by June of the next year. That's it. Thank you.
Thank you. So lots of opportunities to get engaged coming up real soon on this project. So we'll be sure to push that out through our network as well to get some community engagement for you on that. Next up at the regional level is Christy Senatore. Really excited to have her here tonight. She's the executive director of the Cape Cod Commission. She leads the commission in designing innovative land use practices, environmental and community resilience strategies, which is key for us tonight, and comprehensive economic development initiatives. She promotes collaboration among our communities, so I'm glad to see you here in Falmouth and Woods Hole, through information and regionalization projects and the implementation of decision support platforms designed to create efficiencies. If any of you have not looked at their website, it's pretty impressive, and I think she's going to share some of the opportunities to engage you as well tonight. Thanks. You're welcome.
Great, thanks, Leslie, and thanks for the opportunity to be here this evening. It is wonderful to be here in person, and it's really nice to see a successful hybrid event happening. So congratulations and kudos to all of the hosts of this event tonight. So I want to take it in a little bit of a different direction and really talk about some of the work that we're doing at the regional level and talk about some of the support that we're providing to our local communities, some of the decision support tools that we've developed, and opportunities to engage at a variety of different scales. So the Cape Cod Commission is the regional land use planning and economic development agency for the region. We cover all of Cape Cod, all 15 communities, and we work very closely with our communities in developing our regional plans and providing technical assistance. So this evening, in my 5 minutes, I'd like to focus on the development of our climate action plan. So over the course of the past 12 months or so, it was a very, very abbreviated time frame to put together the first ever climate action plan for Cape Cod on a regional scale. Over the summer, we did pass this plan, and we're now in that implementation phase. So as you can see over on the right-hand side of this chart here, the components that are included within our climate action plan, as well as some of the resources that we developed as part of the development of the plan. I'll focus on a couple of these and then really go into that implementation phase where we are now. One of the first things that we decided was necessary as we put together this plan was an emissions inventory for the region. So really trying to get down to a more granular level as to what the emissions are for our region so that not only can we establish that baseline, but we can then use that to measure our performance as we move forward in addressing our regional greenhouse gases. Of course, stakeholder engagement was one of the biggest components of putting together a regional plan like this. And so we engaged over 260 stakeholders across the region in a very short time frame and held over 50 meetings all over Zoom, really to try to break down some of the sectors and really work in some of the focus group areas where we could really put together strategies and we could put together goals that we could attain and really could work with the local communities to develop. So you'll see a couple down there, that priority strategies. I'm going to go into a little bit of detail there, but there's a fairly robust database that's available on our website now that contains a number of goals, and it also contains priority actions and strategies. And so there are a variety of ways that you can sort these different types of actions. And so you can look at this by sector, you can look at this by the type of either individual, organization, community that might be wanting to adopt and incorporate and then implement some of these strategies. One of the other big components of our planning work was an economic and fiscal impact analysis. So it was important for us to get a sense of what some of the strategies would cost in terms of dollars, also looking at some of the social impacts of those, but also what the cost to our region would be if we were to take no further action. So a lot of this information really helped to support the findings and the recommendations that are now included within this regional climate action plan. I mentioned that inventory of greenhouse gas emissions that really set that baseline for our performance measures. So we have a series of performance measures. I think we narrowed in on 9 performance measures. We started with maybe several hundred that we wanted to measure and really tried to focus in on an area that we could really measure the performance as a region and reaching some of our regional goals. In communications framework, we all know how important it is to be able to communicate this type of information, not only to those that are involved and those that are in the room and watching, but the general public as well, and those individuals that can understand and recognize how their actions can actually help in addressing our greenhouse gases and addressing climate change as a region. So the priority strategies, as I mentioned, really are focused here on 11 priority strategies, and these are in both the adaptation and mitigation categories. And so some of them, as you'll see up here, are looking at accelerating the electrification of the transportation system. We know that one way that we can certainly reduce our greenhouse gas emissions is through our transportation network, reducing miles traveled, supporting low and no carbon transportation options. And then one of my, certainly I think one of my favorites in that we're a land use planning agency is promoting efficient land use policies and development patterns that protect the nature and the character of the region. One of the fundamental kind of mapping exercises that we have at the Commission, where we look at our past development and we can take a look at the development patterns across the region as kind of a way to look at our future development and growth, and 86% of the land on the Cape is either already protected or already developed. So that's an important number when we look at regional planning in a variety of different aspects, but certainly in the climate aspect, we know that there's limited land left for future development, so how and where we grow is extremely important, and really focusing our growth policy on opportunities to address climate change, to make more walkable, vibrant communities, really protecting the unique character of the Cape is important as well. So these priority strategies are really what are setting the baseline for information to establish the different actions and steps that are included within our climate action plan. So some of the regional resources that we prepared as part of this climate action planning process are available on our website, as Leslie Ann mentioned, and we have a variety of different resources and tools, but we developed a solar screening siting tool, really looking at industrial scale solar and opportunities where it might make sense to place this type of solar going forward. So this is a robust GIS analysis that a user can go in and look at certain areas that may be more or less acceptable for this type of solar development. As I mentioned before, we know that electric vehicles will likely be a big part of the solution in terms of addressing our greenhouse gases. And so we've got a charging station inventory that can also be, that can be viewed. Our Cape Cod Coastal Planner application is also one that actually really started a lot of the work that we did in our climate action planning process, where you can look at some of the local and regional coastal resiliency strategies on a certain geography. So these are all available on our website. Certainly happy to walk anyone through it. working with the local communities on model bylaws. We have 2 that are available now on our website that are very recent. Our coastal resiliency model bylaw, looking at development impacts within the floodplain, considering some of those climate change impacts, those coastal resources, sea level rise impacts. Model large-scale solar bylaw, and this is similar to the tool in that is designed to help communities manage some of the impacts from large-scale solar. And we're also working right now with several different communities, 10 towns across the Cape, on low-lying roads assessments. We know that infrastructure impacts, and we know that looking at our transportation network is important in terms of looking at climate change. So we're working with many of our towns right now. We're working closely with the Woods Hole Group through a series of public meetings to identify strategies for potential or alternative solutions for sea level rise and storm surge adaptation in the particular areas. And last slide here, incorporating equity is certainly one of the major components of the Climate Action Plan. We want to make sure that vulnerable populations are addressed and not potentially disproportionate impacts. And so ensuring that the implementation process of this plan now incorporates all members of the Cape Cod community is important. And lastly, I want to leave this here. We have also really tried to reach out to the different populations across the Cape, and including the younger populations. And they're very interested and they're very engaged, and we have just launched a student climate ambassador program. We ran a program in the spring. We had many engaged high school students following us through a series of 8 meetings after school, where they would hear from local leaders and they would hear from the science community about these climate change impacts. And so these are high school students that really want to be engaged and want to be climate ambassadors and bring this information back to their schools. So we're hosting a second round of our climate ambassadors program. The call for students is open right now. So if you know any interested high school students, please send them to our website. We'd love to engage. So these are just a few of the things that we are working on at the Commission. Again, this is all available on our website, and I'm happy to take questions. So thank you.
Thank you very much. I know these are flash talks for you. There's a lot of information behind them, so I apologize, but they're not quite TikToks. So we're somewhere in between a long presentation and a TikTok. So hopefully we're hitting the mark here. The next presentation is actually coming to you via Zoom. We're going to introduce Patricia Bowie to you. She's a coastal resiliency specialist with the Massachusetts Office of Coastal Zone Management, near and dear to my heart. I used to be the director there. Like me, she's also a graduate of Duke's Nicholas School of the Environment, so therefore she's on my Christmas card list. She and her colleague Steve McKenna serve as the sponsors of the Phase 3 Resilient Woods Hole initiative through the Massachusetts Coastal Resiliency Grant Program. So they are funding our third stage of work here. So we're just going to promote her to being a panelist, and then she's going to start her quick 5-minute talk. And she's not coming from the International Space Station, I swear.
Hi, thank you, Leslie Ann. Can you hear me?
Yes.
Good evening, everyone. Thank you for having me tonight. My name is Patricia Bowie. I'm a coastal resilience specialist with the Massachusetts Office of Coastal Zone Management. I'm really pleased to be here tonight to share with you a few state level led initiatives that are helping to address challenges of climate change and natural hazards. So as you all know, Massachusetts continues to experience firsthand the impacts that climate-driven events are having on our coasts and our buildings and our infrastructure. And working with communities and stakeholders to advance adaptation planning and resilience efforts has been a priority of the Baker-Polito administration for the last 6 years. Recognizing that climate change is intensifying natural hazard events in terms of increasing severity, duration, and frequency, a significant accomplishment was achieved in 2018 with the adoption of the state hazard mitigation and climate adaptation plan, which is a first of its kind plan that is important because it really outlines the statewide strategy for beginning to proactively plan for climate change and reduce damages from extreme weather events and address future impacts through really forward-looking resiliency measures and adaptation measures and policies. Also, very importantly, that plan maintains the state's eligibility to receive federal disaster assistance dollars. This plan has a tremendous amount of information that I'd encourage everybody to look through related to climate change and adaptation. And it's available on the state Climate Change Clearinghouse website at resilientma.org. And I also want to highlight this resource for a lot of other great information and resources available, including downscaled climate change data and projections, interactive mapping tools, and information on grant funding programs, which I'll get into next. So some of the speakers already alluded to the Municipal Vulnerability Preparedness Program. This is a statewide grant program that enables municipalities to undertake a community-wide planning process to help identify climate change vulnerabilities and risks. And this is looking at a broad range of climate change impacts. So inland flooding, sea level rise, increased precipitation and temperature extremes are all carefully looked at through these planning grants. This really brings local governments and community members together to assess those vulnerabilities, think about what the community needs and values are, and develop an action-oriented plan that identifies what the community's top priorities are for adaptation. So statewide, 93% of the communities participate in the MVP program, and we're very proud that the Cape and Islands communities are all involved in this program. And in total, $65 million in MVP grant funding has been provided for these projects since 2017. A little bit different, but kind of along the same lines is the Coastal Resilience Grant Program, and this is administered through the Office of Coastal Zone Management on behalf of the Executive Office of Energy and Environmental Affairs. This grant program is only open to the 78 coastal cities and towns in Massachusetts and nonprofits that own vulnerable coastal property that is open and accessible to the public. And the goals of this program are really focused on reducing known impacts from coastal flooding and erosion and helping those communities adapt to future conditions like sea level rise. We're really interested in looking for innovative approaches, such as nature-based techniques to help stabilize coastal shorelines, and as well as transferable approaches and products and techniques that other communities can use that are experiencing similar issues. Because these grant funds are state capital dollars, we are focused on really protecting the public facilities and infrastructure at risk, and making sure that projects are providing broad public benefits and access to the coast. And we're also very proud that this program, since it was launched in 2014, has been able to provide $25 million in coastal resilience grant funding for 174 projects. The resilience strategies that we see communities taking through this grant program span everything from vulnerability and risk assessments. So really taking a deeper dive and building on the MVP work to focus in on either a particular area in the neighborhood or economic sector that's at risk to the flooding and erosion hazards. A lot of public education and communication projects to help raise awareness of climate change impacts, engineering and design projects for critical infrastructure and facilities to accommodate higher water levels and greater storm surges in the future. Proactive planning, which could be developing adaptation plans or amending and developing and updating local ordinances, bylaws, and zoning. And then finally, our shoreline restoration category, using nature-based techniques, which would include the traditional dune and beach nourishment projects, which everybody is familiar with, to fringing salt marsh restoration and coastal bank stabilization with biodegradable materials and core rolls, and natural vegetation to help stabilize the coastal bank. I want to finally just dive into really quickly the Cape and Island communities, which have been very successful in the Coastal Resilience Grant Program, with $8 million in funding for 53 projects since 2014. All of the dots that you see on the map on the left-hand side of the screen are locations of projects. And if you'd like more information on these projects, I want to make sure you're aware of the Coastal Resilience Grant Viewer, which is on our website. If you go to the Storm Smart Coast page, there would be a link from there to get more information on all of the wonderful work that these communities are doing. And a few takeaways from all of our projects. I'd really like to stress the importance of the community-wide awareness of risk and raising awareness of the impacts affecting the community resources, providing opportunities for meaningful public engagement in projects, emphasizing the need for long-term planning, depending on what the design life of the asset is. And a great example of the ResilientWoodsHole project, which is utilizing really creative and collaborative partnerships to help leverage funding and expertise and really advance these projects toward implementation.
Thank you. Thank you very much. So now we get to see a really large Patricia on our screen. So I know that I hear through the grapevine that there might be a football game on tonight, which why the beauty of a DVR, right? So you can watch it later. So we are running about 15 minutes behind, but that's okay because this is really important stuff. So I want to thank our panelists, and I would like to open it up to a few minutes of questions and answers. And I think there's a question in the back, Carrie?
Anybody can answer this question, but in all the preparation and assessments that have been done for the Cape, my particular concern is the immediate need to deal with the utility insufficiency issue. With every storm, the outages got longer and worse, and I just wonder if that issue is involved with any of the planning that's being done.
I'll give that to Christy since you're looking at it in a regional perspective. So utility, resiliency, and planning.
Sure, and that's a really important question, and certainly one that I think has got very complicated answers, and so I don't have all of them, but certainly recognize the importance of making sure that all of our utilities across the Cape are coordinated, and so that's something that we'd be looking at in terms of looking at regional capital planning as well. So looking at regional infrastructure planning is important. And where we cite future infrastructure is also important as we look at the climate context. So I think more to come on this, and I do think that you're highlighting very important questions that continue to need to be answered, and we need to continue to coordinate with our local and even more regional and larger utilities to make sure that the appropriate infrastructure is protected and maintained and adapted where necessary.
So it's clearly on the mind of the commission then. Okay, great. I have a question from online, Diana.
Yes. We have major assets in the Woods Hole region, ranging from the Woods Hole Public Library to the various laboratories, the ferry service, the Coast Guard, and it's an important area for the offloading of commercial fishing vessels. All of these assets are in the floodplain. If a storm with the destructive power of Sandy that caused so much damage in New York and New Jersey struck in our region, what is the likelihood that these rare and wondrous assets would remain? Has any group modeled this outcome?
Wow. Well, that's the $64,000 question. Actually, Joe's going to answer all those questions and more in his next presentation. But would anybody like to take a crack at this? Charlie, you've done a lot of thinking about this, haven't you?
Yeah.
You just push the button and wait 2 seconds. And turns green.
Thank you. Thank you. Yeah, we don't have answers yet to those. All of those assets are vulnerable, but the planning to address it is beginning. That's about all we can say at this time. Everyone who's involved is aware of that, and we can hope that with, for example, the infrastructure bill, which has $47 billion to make projects more resilient, and most of that should be spent on things that have to be on the shoreline, and the ones that you mentioned do. So that has to be a priority.
Thank you. Another question from our live studio audience in the back.
Hi, I'm just wondering, I have a property down off of Surf Drive, so I'm right in the vulnerable. I feel very threatened by the storms and the climate change, I believe. I'm wondering, when I watched the Woods Hole group, I went to the Surf Drive back in 2019 at the Gus Canty Center, and they talked about a time frame from 2008, the sea level rise was at 0.8, and by 2030 it was going to be 2.2. So that's like a 16.8-inch rise. We are now 13 years into that 22-year period. I'm wondering, is anybody looking at the results of what is really happening? Earlier in the first panel, somebody was asking that same thing. Are we checking on the model? How's that model coming out to reality?
I'll give that to Charlie as well.
Thanks.
Just keep the blue one, Charlie.
Well, I'd like to pass it to Joe, but that's it. But we're relying on the models that the state has prepared. I think we have to do that. We're not going to come up with an individual model for every stretch of shoreline. We have to rely on larger efforts that are well vetted and base our public decisions on what the public institutions are projecting.
So I guess we'll hold the other half of the answer to that question until Joe gives his presentation, because he may have some more specific information for me. I'm putting him on the spot here, but he's nodding. He's like, I can handle it. I can field this one.
I just wanted to comment.
Sure.
We're more than halfway through that time period, and it would seem very sensible to me to be looking at it and seeing if it's working, seeing if that model is real.
Right. Yeah, I completely agree. Diana, do we have another question online?
Yes. Has anyone looked at potential carbon reduction as a result of the Steamship Authority developing the port of New Bedford for western and northern traffic?
I'm not so sure that anybody in this panel can answer that particular question, but we will field that question to the town and see if we can't get a response on a blog for that. So, okay, we're going back. All right, other questions from the audience? Oh, we've got a lot of them. All right, I'll go to Matt.
So for Amy, since she's so quiet, how are areas of Woods Hole going to do with the gravity sewer system once the streets are regularly inundated during storms and all of it fills up?
So just to, would you mind restating the question because it might have been a little hard to hear?
The question was, how's Woods Hole going to do with our current gravity sewer system when sea level rises and it's flooded more frequently? It's a problem. And looking at the Park Road area is our that's our focus area for this next study. But what we look at there really will be applicable to the rest of the Woods Hole area. The only options really are to make what we've got as watertight as possible, or to convert it to a pressure system, which there then is nearly completely watertight.
And so I assume these are some of the things you're going to be looking at and evaluating during your study.
Yes, absolutely.
Great. One last question from online, Diana, if you have one.
There is one more question. In our houses, we are required to have fire extinguishers in case of fire. I would think that the risk of flood is much higher, so shouldn't we in Woods Hole be required to have a life raft as well as a fire extinguisher?
We are going to apply for some Build Back Better funds so that everybody in Woods Hole has a life raft. A Zodiac. Tom would like a Zodiac. We'll end on that point, actually. Let's thank the panel for their time. Okay, we are going to quickly transition to Joe, who's going to answer all of your burning questions about what is this thing called Resilient Woods Hole. Yep. Good. Come this way. Wanna? There you go. Yep. Thanks. Thank you. Thank you. Let me get it for you. Thanks. Yeah. And I'm also going to leave some of Charlie's reports down here. There you go. Okay, great. So we want to welcome Joe family from the Woods Hole Group with us tonight. Woods Hole Group, and particularly Joe and his colleague Kirk and his other colleague Leslie Fields, have been just wonderful partners for Resilient Woods Hole, for the institutions as we look at our own assets, and now as we expand into looking at the community's assets. Joe is a senior environmental scientist at Woods Hole Group. We won't fault them that they're owned by the French now, but that's okay. Our key analytical partner on the Resilient Woods Hole initiative, focused on environmental and sustainability planning. Joe has expertise in assessing climate change vulnerability and risk for infrastructure and natural resources, and developing adaptation and resiliency plans for communities and organizations, which is a long way of saying we're in good hands with Joe and Woods Hole Group. So with that, I will turn it over to Joe to talk about our phases of our project and what's coming up next.
Thank you, Leslie Ann. It's great to be here with you all tonight. One thing I would say is that even our French ownership actually gives us access to a lot of neat satellite data that is actually informing a lot of these climate projections. Bring that night. Is that better? I have a difficult task here today. I have to roll a summary of 3 different projects into a very short timeline. So we're going to go through this pretty fast. I would be remiss if I didn't say that in addition to all the great science and research that's happening here in Woods Hole, that we also benefit from a great record of observation that's local. And that record informs our sea level rise projections. It informs the ability of climate scientists to downscale regional and global models to the local level, and the state has certainly benefited from that. And it also provides us a record of storms over time, and that informs the modeling that we do to help communities plan for storms and for climate change. So to get started, Resilient Woods Hole, the first phase of our project really focused on assessing the risk to the facilities and assets of the institutions here in Woods Hole, WHOI, NOAA, and MBL. And we conducted a climate change vulnerability assessment looking at sea level rise, and these are the climate projections that are provided by the state that inform our model. And a large historical and future storm set. So actually, maybe I'll back up and answer your question right here. So these projections, there's a long answer and there's a short answer. They consider a range of probabilistic assessments of different climate scenarios, different greenhouse gas emission scenarios, and the response of sea level rise over time, both thermal expansion and ice sheet melt. So that there are a number of different emission scenarios, as you know, whether or not we take a very high trajectory of greenhouse gas emissions or begin reducing drastically now, which doesn't seem to be happening. That said, what we like to tell communities is that these projections, they consider the science and also they should be used flexibly. So if the thermal expansion and ice sheet melt doesn't occur along the timeline that these are projecting, they can shift off and into the future so that we are planning for the next scenario. Hope that answers your question. If you have a follow-up, we can certainly talk in more detail later. So in order to inform this climate vulnerability assessment, we used a probabilistic hydrodynamic model that we developed for MassDOT, primarily first to address flooding in the Central Arctic Tunnel in Boston, but later on to the entire coastline of Massachusetts. And it's hydrodynamic because we know that storms don't act in a bathtub. This is a visualization of a storm 12 feet and AVD 88 visualized against the land elevation in a static way. So similar to a lot of the viewers that you see online. This is the same storm modeled hydrodynamically. It's a nor'easter, so wind and waves are pushing water and piling it up on the south shore. And you can see there's a wide range of water levels that result from that. We do it probabilistically because it helps communities and asset managers plan their investments in adaptation over time and really prioritize those risks. So what goes into our Massachusetts Coast Flood Risk Model? We have those sea level rise projections. We have more frequent and more intense coastal storms, both tropical and extratropical. We incorporate roughness coefficients from the landscape because water flows more freely over paved surfaces than undeveloped surfaces. There's the elevation gradients throughout the area. And we put that all together and include all of those relevant physical processes that affect water levels. So winds, waves, run up and overtopping across the landscape. And the primary output that we get is these flood probabilities. So the chance of flooding on the land surface in a given climate scenario. We can also calculate flood depth by comparing the water surface elevation to the land elevation. And then if we dig a little bit deeper into the results, we can develop some estimates of flood duration. Obviously, a concern here in Woods Hole with the park and the lift station, as Amy was referring to, and look at flood pathways and extract information about winds and waves and currents. So these are the results of the probability results, and you'll see here, attempt to do this. This range of probabilities goes from 0.1% all the way to 100%. That pink is sort of a 1,000-year recurrence interval, 0.1%. 1 is a 100-year kind of 100-year event, and 100% would be the annual storm. So there's a wide range of probabilities. It's the chance of flooding during a calendar year. And as you see, as we step through these maps, that probability increases over time, both at the location, and it also expands as those water surface elevations get higher. So we used this model to assess the flood risk and basically the consequence to the three organizations. And so we did an inventory of the assets. We looked at the critical elevation, so the level at which the water would have to get in order to impact the building or the generator or whatever we're looking at. We asked each organization to consider how loss or damage to that asset would impact their ability to function and the ability to carry out their mission. So we scored that consequence in that middle slide. And then we combined those two things, the probability, which is the probability of water getting above that critical elevation, and the consequence to get an assessment of risk. And we did that for all three, WHOI, MBL, and NOAA. So that helps to start prioritizing and making lists and choosing when and where to act and how. We also started looking at nuisance flooding. So because of those local measurements that we benefit from here, we can develop very good future tidal benchmarks. So we started mapping out the mean higher high water throughout the village, present 2030, 2050, and 2070, and started seeing some impacts, as you can see here, coming over Gardner Road through the park and along Millfield Street, primarily, with a little bit around the edges of Eel Pond. Then we started thinking about things that we could do to adapt to both sea level rise and storms at the facilities at WHOI and MBL and NOAA. And these are just really quick examples of some of the district level adaptations that we started thinking about. These are all just sort of conceptual level and primarily focused on kind of phased incremental modular walls and deployable barriers so that we could keep storm surge out of these facilities. Same thing here with Lily, where we stand today, which has experienced flooding in the basement in prior storms, looking at some modular wall elements along Eel Pond, tying them into the buildings, and providing some deployable barriers and perhaps a landscape element around the edge to link it all together. And for NOAA, a similar approach, but the deck that NOAA has where they work from could be inundated under tidal conditions in the mid to late future. So we started thinking about some elevation for the decking there, as well as some building floodproofing. In the next phase, which we're just completing right now, we started thinking about what are the impacts beyond the research organizations here in Woods Hole. What are the impacts to the community? What are the impacts to the business association, the businesses here in Woods Hole? What are the impacts potentially to the lifelines that exist here, the Coast Guard and the ferry, as well as the town infrastructure? So we've been working with Amy in the town to get a good understanding about the work that we've already completed on the sewer infrastructure and the drawbridge. we started looking at the structures that exist within our study area. So this white area is defining our study area, starting with where the surf drive assessment left off. Looking at building footprint exposure to flood risk over time, and how that evolves over time. So the stats that you see on the right are the number of buildings that could be exposed to a 1% chance storm over time. And what we found as we advanced through the flood risk model results is that, I'll just highlight the residential buildings here and the business community. I think it was about a quarter to a third of residential structures in the study area could be exposed to a 1% storm between the 2030 and 2070 conditions. And I think it was about 60 to 75% of the businesses. So we looked at the building use and also found that a large percentage of the lifeline infrastructure was potentially vulnerable. We also started looking at a very fine-scale assessment of inundation to the road segments and looked at how that evolves over time. There's a more risk today at along Eel Pond on the backside and Millfield Street, but as it evolves over time, there could be access issues on both sides of Eel Pond. So something to think about in terms of planning and how we work with town to support everything that happens here, including the science and the residents and the businesses. We did a initial flood pathways analysis to look at low-level flooding, so like a small storm that might come through. What are the points where we could potentially have some success in blocking some of the flooding that might come through? We found some early entry points at Gardner Road, as well as from both sides of Millfield Street. An interesting one from underneath the bike path, from the bike path underneath the overpass to the ferry. And then later on in a larger event, potentially through Millfield Street, through the MBL campus and from Water Street. We have also started looking at some small targeted solutions that hopefully the idea being could prevent flooding with minimal investment, looking for targeted places where, assuming we do something at the edge here on Bigelow to address flooding from the deck and from Great Harbor, there are some other vulnerable points within some of these facilities that we would need to address as well. So there are floor drains in a lot of these laboratory buildings. In this case, there were 3 different drains coming out of Bigelow that drain off of the Island dock. And we'd be looking at ways to do some sort of valve or backflow preventer so that the storm surge wouldn't get into some of those the rooms that house the mechanical equipment. For MBL, one example that we looked at was the seawater pump house right across the street here, where we have a door and some a deployable barrier on that door, plus some building floodproofing could really reduce the risk to that facility, which supports all of the experiments and investigations that go on here. And finally, one interesting case that we found at NOAA Fisheries was a vent between the basement of the aquarium and the gear shed that could potentially allow floodwaters from the gear shed into the basement where they have all of their equipment for the aquarium water treatment systems. And so we started thinking about a small deployable barrier right around that vent or a small constructed wall to alleviate that risk. And finally, we looked at a couple more building level adaptations for HUI and MBL. At Redfield, we explored both a system of deployable barriers, maybe in the near term, that would be easily put out in the event of an oncoming storm, that would tie into the existing wall elevation on Water Street. And that would actually reduce a lot of flood risk for that facility. An alternative to that, built to the same elevation, we could consider a wall at the edge of the parking lot, as well as some landscape element to provide some more of a public amenity and a park feature. And both of those, and that system would also require some sort of passive barrier that could be activated to keep water out of the parking lot. Over at Swope, we looked at ways of leveraging the existing walkway and elevating that wall, tying it into some potential landscape features to keep storm surge that comes from Buzzards Bay and from Great Harbor from penetrating into Swope and potentially Ebert Hall. And then potentially using that as a stepping stone to a more landscape public amenity element to provide the same level of protection. And finally, the next steps that we're about to embark on, and we've started by talking to a number of stakeholders throughout the village, is to use what we know about vulnerability throughout the village to start talking with everybody to develop a common level of understanding and building these partnerships and starting to consider the short, mid, and long-term strategies that we might adopt across a few different themes and try to choose a path that's most preferable and acknowledging tipping points along the way. So if there is a certain time window under which protection makes sense, then we should use that path as much as we can. And then if there's a preferred path past which, at which it makes sense to transfer to a different approach, then we would want to take advantage of that. So it's a very similar approach as we used in the Surf Drive project, with the goal of developing these flexible adaptation pathways. This is the schedule that we're working with. As Leslie Ann said, we're funded by the Coastal Zone Management Coastal Resilience Grant Program. We'll be working throughout this year into the spring to develop these adaptation designs and working closely with the community and our steering committee, which is representative of all of the interests in Woods Hole, to chart a path forward. And trying to bring that all together into a flexible adaptation plan for delivery this summer. So thank you very much. I would also say that part of the engagement that we're doing on this project is getting a sense of the community preferences for what we do here in Woods Hole. And as the website goes live in the near future, we'll be having a survey available for everyone to participate in.
Great. Thanks, Joe. Don't go anywhere. I'm sure there's lots of questions because that was a lot of information in a very short amount of time, and I'm sure it's very overwhelming. I'm actually going to invite Rob and Paul and Nicole to hop up on the stage too. These are our 3 champions of Resilient Woods Hole. You coming this way? Okay. All right. So I know we're running a little behind, but we're almost at the end. But wanted to make sure you got a chance to ask some questions. But before you did, of Joe and our 3 champions here. So I wanted to introduce them. They have just a really brief remarks that they each want to give from their seats. I don't give them 5 minutes. I think I gave them 30 seconds or a minute. But so I want to introduce you to Rob Munier. Rob is the Vice President of Marine Operations and Facilities at WHOI. Paul Sphere, who is the Chief Operations Officer at MBL and also a WHOI Joint Program graduate. And Nicole Cabana, who is the Deputy Director of the NOAA Northeast Fisheries Science Center. So I think I'm going to start with Rob? Okay, go ahead.
Yeah, thanks. Good evening, everybody, and thanks for hanging in there. I know we're running a bit late. I want to thank MBL for hosting this, and this is fantastic to have a hybrid event that's really quite successful. We have a great turnout here and online, so really appreciate that. I also want to thank Woods Hole Group. They're a true partner in this, and also my partners, which are MBL and Fisheries. We've gathered together to create this Resilient Woods Hole process, and tonight's a great example, I think, of that outcome, and I really appreciate that. And I also think it's important to recognize the town of Falmouth for a couple reasons. They're sort of been supporting our activities, but also they've provided really a model for us to start from. So the Surf Drive project really allowed us to have a template to use, and we've been sort of running with that. So thanks to the town of Falmouth for that. And our initial motivation at Hui was a waterfront project. Many of you might be familiar with it. And we realized pretty quickly that sea level rise was going to underpin all of the plans that we might have for redeveloping that waterfront. And then we've been looking more broadly at other waterfront assets, and that's been sort of the motivation behind this. And we also know that with our fellow institutions that we have a certain responsibility to lead in this area. So not just for our own self-interest, but also to bring the community along. And that's really what this is all about, and that's why this coastal zone management grant that we received allows us to do that, and is going to facilitate this process, for the rest of into June. Next, Paul, you want to hear?
Oh, well, thanks, and again, thanks everybody for coming out tonight. And I really want to thank Woods Hole Oceanographic for showing the initiative to get this effort going. I arrived here in my job in 2014 from a long stint in Washington, D.C. after the joint program. And after about a year or so, maybe 2 years, and a bunch of Northeasters, I was reminded about the New England coastline, and I began to think about issues with regard to my own campus. And it's when you start thinking about that, it becomes very complicated very quickly. How do we deal with this? How do we think about our place and all the issues within our own campus? And as the Grateful Dead always tells us, the first days are the hardest days. So we spend a little bit of time trying to figure out what's going on, and the initiative from Woods Hole Oceanographic to get on this was extremely helpful to us. The MBL has been here a long time. We don't have any particular other place that we could possibly be. We need to be here near the water anyhow for a whole variety of reasons. So we're going to have to figure out how to live here. But I think the other thing that's very important from our perspective is that our campus probably almost uniquely sort of spans a good portion of the village of Woods Hole, from Stony Beach back up through our main campus here, and then up over to Waterfront Park. So we sort of feel like we're very much in the heart of this community. We know, despite the discussion of adaptable walls and things like that, that we are not going to build something like Winterfell here to, sort of guard us from the waters. We're going to have to figure out smart ways to do that. And importantly, we're going to have to figure out smart ways to do that with the community in which we sit. So we're very enthusiastic to be part of this whole effort. And we certainly are looking forward to this next year, where we're going to go from sort of our old inward-looking approach to working with you all, the town, and the village of Woods Hole. So thanks very much.
And I'm the last speaker of the night, but I want to echo some of the things that Rob and Paul both said. As the Deputy Director of the Northeast Fisheries Science Center, Woods Hole is extremely important to us. Our mission is to provide scientific research regarding commercial fisheries and protected species from the Canadian border down to North Carolina. And being located in Woods Hole is a central location that allows us to best accomplish that mission. It's also very important to us to be located here, to be co-located here with our partner institutions. That enables collaborations that would not be possible otherwise. And it also has resulted in Woods Hole being a world-renowned marine science hub. And so we're grateful to be partnered with Hui and MBL on the Resilient Woods Hole work. And one of the things that's also important to us in the work that we do is community involvement. And we work with stakeholders throughout the region. and we greatly value the contributions and perspectives that stakeholders bring, and we find tremendous value in looking at complex problems with the communities that we work within. And the exact same thing is happening here. So we're excited to be working with all of you. We're excited to have you joining us tonight as we enter into phase 3 of our Resilient Woods Hole work. We look forward to working with every single person in this community to actually making Woods Hole resilient. Thank you.
Thank you very much. I just want to say this is not just the 3 institutions that are working on this. We have a brand new steering committee as part of our phase 3 effort, and it includes representatives from WHOI, MBL, and NOAA, of course, but also the Coast Guard, Steamship Authority, USGS, the Business Association, Woodwell Climate Research Center, 4 offices in the town of Falmouth, which includes the town manager's office, the Conservation Commission, the planning office, and the wastewater department, so big kudos to the town. Neighborhood representatives, the Massachusetts Office of Coastal Zone Management, and our newest member to the steering committee is Peg Brandon from SEA, who's up in the back tonight. It's the Education Association. So we really hope that we've put together a pretty robust steering committee to steer the next effort in Resilient Woods Hole. And with that, I know it's a little bit, we're 20 minutes behind. That's okay, because there probably isn't any score in the football game, so don't worry. But I would like to open it up to questions because I know Joe presented a lot of technical information, and you have the 3 institutions who have been cheerleading this effort so far. So does anybody in the room have questions for anybody on the stage currently? The gentleman in the back again. Glad you came tonight, sir.
Thanks. I have a lot of interest.
Yep.
Again, I guess it would be for Joe. First thing, on your second or third slide, you showed a new curve of like 2030 being 1.4 feet, whereas I say back at the 2019 Surf Drive study that they did at the Gus Canty Center, it said 2.2 for 2030. And all of the illustrations and everything are based on that 2.2. And then I guess the main question would be is, do you go back and test the model all the time? So we're 13 years into that prediction back at the Gus Canty Center. From 2008 to 2030 would be 22 years. We're 13 years into that. Do we go back and look at where we are today based on the predictions of where we should be in 2030?
So a couple answers to your questions. First of all, I'm not sure what the numbers that were presented at that slide were. Sometimes there's a difference between elevation and change. Could also be meters versus feet. But we could certainly look into that in a little more detail. All of the sea level rise numbers that we use are based on the state's sea level rise projections. There's slight differences depending on what tide gauge you're looking at and where those projections are. And the model that we have created for MassDOT uses a south versus north. North is primarily the Boston gauge. South is sort of a hybrid between Woods Hole and Nantucket. But in terms of how are we looking at sea level rise over time and why isn't it keeping pace with some of the projections? There's a number of different answers. There's feedback loops that may not have engaged yet. The science on ice sheet melt is always evolving, and I'm not the person to talk about that with any kind of authority, especially in this room. But talking to some of those experts, they're adjusting their projections continually, and depending on what emission scenario you're looking at, some of the projections are coming down, but others are going up. So there's this interesting tipping point with the sea level rise, with the ice sheet melt, which is, by the way, the massive contributor to those numbers. If it goes one way, the ice sheet contributions from land ice is a little less drastic because it doesn't feed back on itself. If the emissions go a different way, then there could be rapid feedback and warming and loss there. We're in the process of updating our model and talking with the experts on those projections and for the next round of modeling, yes.
Yep. So I think the answer to your question is yes. They're always updating the models based on observations. Correct? Oh, you need to use the microphone, sir, because the people online can't hear you. Unfortunately.
I'm sorry. The town is looking at making new policy based on the charts and everything they were presented back in 2019, and he pretty much said he's not looking back or looking forward to see if it's changing. He's going by what he got in 2019. So, I'm just saying we should be looking at that. I won't take any more of your time.
No, that's okay. I want to make sure you were heard and your question is answered.
Yeah, I'd like to.
And I'm going to have Rob wants to jump in.
I'd like to just jump into this a little bit, and we're always trying to pin Joe down with a hard number because we're trying to plan something. And it's interesting because tonight we started with our science discussions, which were talking about models that were sort of global in nature, and then we asked Joe, and we've got it sort of regional in nature, and even down to right up and down the street. From a pragmatic standpoint, how do you plan for your infrastructure? And one of the tenets that we've come across is, you're balancing how long is your infrastructure going to last and how high is the water going to go. And so you can design to a height or you can design to a time. And we're inclining to looking at a height because that way we'll know that it'll last until it gets to that high. So your question being, is it going to be 30 years from now or 45 years from now? We don't have to worry about that. We have to worry about the height that we're going to design to. Because you'd like to have an infrastructure that says a 75-year infrastructure, a 50-year infrastructure. Maybe that type of thinking doesn't work in this kind of a scenario.
That's what we're doing. I'm going to take. Is there a question online, Diana? I don't want to ignore our online audience. We have almost 200 of them. So
No, there aren't for this panel. There are several questions for the scientific panel that didn't get answered, and as you mentioned, we can put them on a blog on the ResilientWoodsHole.org website.
Okay, so you don't have any online questions for this panel?
Not for this
Okay.
panel, no.
Okay, great. All right, Charlie. I'm sorry, Jerry. Jerry was first.
Just a quick question. Does the concept of abandonment or migration enter the discussions at all?
It does, yeah.
And was that point number 4 in phase 3, your threshold concept?
It is one of the, so in the Surf Drive project, that was one of the themes that was explored. And one of the pathways that could potentially be looked at. So past a certain point, the question was, does it make sense to continually repair and provide services along a roadway? That's a valid question. How the town ultimately decides to deal with that is a separate question.
So yes, it's an option on the option tree. Another question? It's coming right behind you.
So we probably don't want to use the V word, Venice, but thinking of Venice and Holland, how did they do it socially? Did they do it in the past? And how are the Maldives doing it? What can we learn from places that are even more in the path of the storm than we are? Thank you.
Well, I'm going to give that question to Rob because we actually have been consulting with them.
Yeah, so they've been worrying this problem for about 500 years, and they've done a pretty good job at it. And they've provided some real insights. The Port of Rotterdam has provided some consulting to us to help us think about how we might build a port facility with sea level rise in mind. One thing that they will say that is a lot different than here is the regulatory regime and their ability to do things more flexibly, perhaps, than we can here in the U.S. And that was probably their number one takeaway from. We attended a conference together in California and listened to all the ports up and down the coast of California talk. And their one takeaway was, you guys got your hands tied behind your back and aren't able to do the things that we can do in the Netherlands. So I think the regulatory regime was one of the key learnings from them.
Other questions? Okay, great. Oh, one more way in the back, Carrie. Sorry.
following up on the issue of regulatory regimes. On Cape Cod, it seems like every town has its own different way of doing planning and zoning and stuff. I think, is the Cape Cod Commission really, sorry, this isn't really for you guys.
She's still here. We can have her answer.
Putting together sort of best practices, and are towns actually looking at maybe restructuring how planning is undertaken?
Okay, since we have Christy and Tom here, we're going to ask both of them to answer this question.
Thanks. So briefly, the commission is developing resources for the community. So the model bylaws that I mentioned, we're working on resiliency initiatives with the local communities and trying to provide as many resources that the communities can then implement and adopt on their own. So that technical assistance piece is where the Cape Cod Commission is really playing a more important role than in kind of that regulatory framework. So really trying to make sure that we can provide the information and the resources to the communities that can then adopt and incorporate the changes that they might need to on the local level to make some of these resiliency efforts and initiatives easier and more something that's easier for implementation on the local scale.
Hi, I'm Tom Bott. I'm the town planner here in Falmouth, Mass. And there are, we're very fortunate to have a lot of models. We're very fortunate to have a lot of insight. We're very fortunate to have a lot of brain power here. But on the regulatory side, and perhaps sometimes the lack of regulatory side, is creating zoning in Massachusetts is a very Byzantine operation. We have meetings twice a year. And in that twice a year, we talk about how we're going to create zoning. We talk for 2.5 hours on Monday night about doing mixed-use residential commercial overlay district. Zoning requires a 2/3 vote. So for everybody who hates an idea, twice as many people have to like it. And retreat is one of those things that we have talked about in municipal vulnerability. And when you talk about retreat and when you talk about compensating people to say, you have a lovely spot here. It is fabulous. Everyone loves it. We cannot maintain the infrastructure here infinitum. How do we go about compensating those people to say, you have to move from this glorious spot? It isn't easy, but the good news is we are aware of the problem in that 12-step fix to zoning. The first thing is being aware there's a problem. And so we're aware of the problem. We have excellent resources. We just have to have the time, the bandwidth, and the capacity to do those things. Charlie talked about staffing levels for some of these coastal issues. We're aware of them. We're working on them. And we hope for the best. But there's nothing that happens overnight, even though we work at night oftentimes. Thank you.
Great. And on that note, we really hope you enjoyed the evening. We thank you so much for participating. We hope that you feel part of the initiative and continue to participate. In short order, we will open a full Resilient Woods Hole website. We'll share our past and present resources, most of the stuff from Woods Hole Group, and launch the community stakeholder survey that Joe mentioned, because we really want to conduct a thorough visioning process. So please stay tuned and we'll be in touch. If you have any specific questions, comments, thoughts, or ideas, info@resilientwoodshole.org. And you can always find me at lmcgee@hui.edu. So want to thank all of our panelists tonight and everybody for coming. This is a really hard topic. We understand that it raises a lot of uncertainty, and with uncertainty becomes anxiety. We want to make sure that you know that there's a lot of us working on it. There's a lot of us who care about it, and we're in this fight together. And we want you to continue to participate and communicate with us. So thank you very much for everybody for tonight.